For 5.2, our first section is graphing a system. I'm going to graph f of x first. So I take my equation. If I plug a 0 in, -0 plus 10 is 10. If I plug a 1 in, -1 plus 10 would be 9. These are 2 points I would plot on my graph. 0, 10, dot, 1 up 9, dot. My line would autofill. You'll notice it's going down 1 over 1 each time. Then I will graph g of x. When I graph g of x, I have a fraction, so I will want to be careful and plug specific numbers in. So 0 is really nice because it'll make my fraction go away and just be a +9. And then if I plug a 4 in, that'll cancel out my 4. -3 plus 9 is 6. These 2 points I will plot on my graph. 0 is at 9, and 4 is up 6. I then can identify the solution where it intersects. My intersection or my solution is at 4 up 6. Right here. Now, graphing inequalities is new. I'm going to make a little chart table. I'm just going to do it up here in this corner where I have room. Okay, so if I'm going to have a solid line, that means my inequality will have a line under it. If it is going to be a dashed line, it will just be an inequality with no equal sign under it. The other thing you'll have to ask is where you shade. This means that it is less than the line. So these inequalities you would shade below. When it's a greater than inequality, you will shade above. So now what happens is I can use this table to help me know. So I look at my inequality sign. It will be a solid line. And I will shade less means below. Now I'm going to graph this just like I do my other lines. I'm going to find 2 points that will work on it. So let's see. I have 3x plus 4 is my equation. I'm going to replace the x with a number on my calculator. If I plug a 0 in, 3 times 0 is 0, plus 4 is 4. If I plug a 1 in, 3 times 1 is 3, plus 4 is 7. These are 2 points that would create my line. 0's at 4, 1 is at 7. Then I have to select the correct line. It should be a solid line. Solid line. And then it says I shade below it. To shade below, I put my pen on the line. And below means below. So wherever I drag and it ends up filling in, that's where I'll shade. Now that I've graphed it, there will be a little box on your assignment, and it will ask you to name one point that is a solution to the inequality, and one point that is not a solution. A solution is a point that is in the shaded area, so you can pick any point in the shaded area. I'm going to say the point over 2 up 1. I'm going to say this point is a solution. It's in the shaded area. Not a solution. I'm going to pick a point that's in the non-shaded area. I'm going to pick -2 up 7. That point is not a solution. If you want to check your work, it says show algebraically and graphically your points are correct. Graphically, I have shown it. Algebraically, I would take my equation. You don't have to write this in your box. Y is smaller or equal to 3x plus 4. If I put a 2 in for x and a 1 for y, that would be 6, 7, 8, 9, 10. Is 1 smaller than 10? That is true. That is why this is a solution. If I plugged this in for my equation, x and y, 7. 3 times -2 is -6. -6 plus 4 is -2. 7 is not smaller than -2, so that's a false. That's why this point is not a solution if you want to test your inequalities. You do not have to show this on your homework. On your homework, you would just graph, identify a solution, and not a solution. Okay, question B. I look at my inequality. There's no line, so that means it'll be dashed. I then look and see that it's less. That means I shade below. I will use this at the very end when I graph. I need to find points for 7x minus 2. I'm going to plug numbers in. When I plug in a 0 on my calculator, it'll equal -2. That would be my point. If I plug in a 1, 7 minus 2, 7, 6, 5. So 1, 5 would be my point. Then Once I have those 2 points, I would select that I want a dashed line, and I would click and click, and it would fill in the dashed line. And then I shade below. So I put my pen on my line and I would shade below it. That means I'm shading on this side below it. I will then fill in what is a solution. Anywhere in the shaded area, you can pick any point. I'm going to pick the point 6, 0. That would be a solution in the shaded area. Not a solution would be anywhere filled in here. I'm just going to pick this point at -3 up 2. And submit. Alright, I look at my inequality. If there's no equal sign, it'll be a dashed line. It's greater, so I will shade above. I then plug in values to -3 over 5x plus 2. And I would use my calculator to plug values in right here. If I plug a 0 in, 0 would output a 2. If I erase that 0 and plug in a 5, it would be -3 plus 2. I plot my points and make sure it's a dashed line. So 0, 2, 5 is down 1. It would be a dashed line. And I would shade above it, so I put my pen on my line and go above. This is above. If it asks for a solution, I would label any point in the shaded area. I'm going to put 0, 8 as a solution. And not a solution is 0, -8. It's not in the shaded area. Okay, next one. I look at my inequality. It will be a solid line and it will be greater, so I will shade above. When I graph this one's different because I don't have a place to plug a value in for x. Y is always -6, and I can pick any numbers for x. 0 is down 6, 1 is down 6. It is a solid line, and I would shade above it. For my solution, I'm gonna say this point right here, +2 down 3. And for a non-solution, I'll say +2 down 8. We are going to review graphing linear equations. We are given 1.5x plus 2. I'm going to replace the x with the values that they request from the inside. So I would plug in a -2 right here and a -1. I would plug in 0, 1, and 2. If you want, you can use Desmos. Then I would just replace the -2 with a -1, then a 0, then a 1, then a 2. It will then ask me to plot all of these points on my graph, plot the 5 solutions found. -2 is down 1, -1 is up a half, 0 is up 2, 1 is up 3.5, 2 is up 5. Then after I plot all those points, I select graph line, and I will graph the line through those 5 points. Our second part for review is filling in the blanks of a table, recursive explicit equations for each sequence. For arithmetic, that means I'm adding. To get -19 to go to -4, I'm adding 15. I then need to divide that by 1, 2, 3, 4, 5 jumps, which means I'm adding 3 each time. That would be -19, 18, 17, 16, 13, 10, 11, 10, 9, 8, wait. My bad, it's adding 5 each time. 15 divided by, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, goodness, 7, 6, 5, 4. Okay. So we filled in the blanks. If it asks you for what the difference is, I would say the difference is 3. If it asks you for recursive, I would say f of n or f of x, f of n minus 1, adding 3 each time. And if it asks me for explicit, I would say f of n equals my first number from my list. I'm adding 3, but because I picked the first number from my list, I would put n minus 1. For geometric sequences, I'm not adding, I'm multiplying. So I'm going to undo this by saying 80 is divided by 5. That would be 16. Then I need to break it into 1, 2, 3, 4 equal parts. So I would use the root into 4 equal parts, which should equal 2, 8. I'm pretty sure it's a 2. R is 2. Let's test it. 5 times 2 is 10, times 2 is 20, times 2 is 40, times 2 is 80. If it asks for recursive, I would say f of n equals f of n minus 1 times by 2. If it wants explicit, I would say f of n equals my first number, which is 5, times by 2. because I picked 5 as my first number and I times it by 2, I would now put n minus 1 up in the power. Here it's not a power when I'm adding, but when I'm multiplying it moves up into the power.